What if I told you that one day we can replace disease and damaged heart tissue with engineered heart tissue? Why does that matter? Well, when you have a heart attack, a huge volume of tissue is lost, and as a result, this can lead to heart failure and eventually death. To make an engineered heart tissue, we can take cells from your body and reprogram them to become stem cells. Here in Lipke Lab, we take these stem cells and mix them with a biomaterial and turn them into engineered heart tissues through a process called differentiation. We need to make really large engineered heart tissues, and the way I'm tackling this problem is by taking smaller engineered tissues and using them as building blocks to make larger sized tissues, kind of like little Legos. And what's really cool is that these tissues spontaneously start beating. So we're using these really small tissues to make really large tissues, such that hopefully one day we'll be able to fix your broken heart. My name is Justin Harvell from the Department of Chemical Engineering, and this has been Awesome Science in 60 Seconds. War Eagle.
So we've all likely heard about cancer and other metabolic diseases that affect millions of people around the world. A growing area of research called tissue engineering is able to model relationships and treatments outside of the body while mimicking conditions we would see inside of the body. I have been working on a tissue model of colorectal cancer that mimics an obesity-induced, insulin-resistant environment outside of the body. Insulin resistance refers to a condition that occurs when the body's cells become less responsive to insulin. This is more common in people who are obese due to the excess amount of fat in their bodies. Therefore, obesity-induced insulin resistance is an important factor to study to better understand these relationships. I have gotten some promising results for the effectiveness of this model. Shown here are the 3 conditions of cancer tissues grown over 2 weeks. In each of these conditions, the area grows over time and the edges become more irregular, with the insulin-resistant condition growing more than the rest. This mimics what is seen inside of the body and shows that the model represents insulin resistance. In the future, the goal for this model is to better understand and further develop the link between obesity and colorectal cancer, as well as potentially be used to test and advance treatments. Hi, my name is Grace Hester in the Chemical Engineering Department, and this is my Awesome Science in 60 Seconds. War Eagle.